Good morning, students. We'll start the first theorem, that's what basic proportionality theorem. What the theorem says, in a triangle, if the lines are parallel, the ratio of one side and the ratio of the other sides are what? Ratio equal. See the first theorem. Okay, this is a triangle. I'll draw a parallel line here. So what is given here? In a triangle, the lines are what? Parallel. In triangle ABC, what is given? Line PQ is parallel to line BC. And what you have to prove? You have to prove the ratio of this side and the ratio of this sides are what? Equal. So that is to prove. The ratio of one side is what? AP upon PB is equal to AQ upon QC, right? This is we have to prove. Now comes the construction. What is construction? Join BQ and join CP. Alright? Join BQ and what is that? CP. You have to join it. Now comes the main theorem. Now if you see the triangle APQ and triangle BPQ has the same vertex Q. If the triangle has same vertex Q, what is same? Heights are same. Okay? Understood? Now see. The first, the proof. Statement and reason. Okay? Can you start once again? Which triangle I told you? APQ and triangle BPQ has the same vertex Q. If the vertex is same, what is the height is same? So this is the height you can say. So therefore the base are what? Same. Base are same. So once again, see here. Proof, statement and reason. Which triangle we are taking? Triangle, area of triangle APQ and area of triangle BPQ. Which is the vertex here? Q. So what is same? Height is same. So the area is proportional to the base. What is the base here? For first triangle AP. For the second triangle, what is the base? PB. So we can write here AP upon PB. Reason, triangles with equal height. Equal height. Okay. This is the first step. Okay. Come to the second step. Now same triangle here. Triangle APQ and triangle CPQ has the same vertex what? P. Once again same vertex P. So height is what? Same. So what is the base? AQ. For the other triangle, what is the base? QC. So here second step, area of triangle APQ upon area of triangle CPQ. What is the base here? That is AQ upon QC. Reason is the same. Triangles with equal height. Now comes the third one. Since in the construction what we say, the lines are what? Parallel. This is given that lines are what? Parallel. In the parallel lines what happen? Heights are what? Same. As well as triangle BPQ and triangle CPQ has the same base PQ. So both the triangles have same base and same height. So we can say area of triangle BPQ is equal to area of triangle CPQ. Why? Because in a parallel, what is same? Height is same. As well as what is the BPQ and CPQ has the same base PQ. So we can say triangles with same base and same height. Right? So from 1, 2 and 3, what you can say? This ratio and this ratios are same. How? See here, area of APQ, here area of APQ. Okay, area of triangle. Here BPQ and CPQ, they are equal. So this ratio and this ratios are what? Same. So we can say from 1, 2 and 3, area of triangle APQ upon area of triangle BPQ is equal to what? Area of triangle APQ upon area of triangle CPQ. What is the reason we write here? From 1, 2 and 3, right? If the ratios are same, see the left hand side is same, so the right hand side is also same. So we can say, what is the ratio of this one here? AP upon PB is equal to what? AQ upon QC. Understand? Hence, the theorem is proved. Okay. The second theorem, that is angle bisector property. What the bisector property says? In a triangle, the angle bisector divides the side opposite to the angle in the ratio of the remaining sides. Means, see here, this is a triangle and this is a bisector. Which is a bisector here, students? AD is a bisector. What a bisector does? It divides the angle into two equal parts. But what is the angle bisector theorem? So, this is the bisector, the ratio of the bisector. Which is the bisector? This is the bisector. Which is the opposite side here? This one. So, the ratio of these two is equal to the ratio of the remaining side. Means, what is the ratio here of BC? BD upon DC is equal to what? AB upon AC. That is the theorem. So, what is given here? In a triangle. In triangle ABC, which is the bisector here? AD is a bisector. AD is a bisector. AD is a bisector. Of which angle? Of angle BAC, right? Now, what the property says? The bisector divides which side? BC. What is the ratio of this one? It will be BD upon DC is equal to the ratio of the remaining sides. That is what? AB upon what? AC. Right? Students? Then the construction. Here, draw a parallel line. From where? From C. From C, draw a parallel line. Parallel to which one? AD. So, draw a line CP. Draw a line CP parallel to what? AD. Okay? What right here? Draw a line from a CP. Draw a line CP parallel to what? AD. Parallel to AD. Then extend which one? BA and intersect at P. At P. So we'll this one intersect at what? P. At P. Okay? This line we draw. Now see carefully. Okay? Now what do you say then here? Now this line AD is what? Parallel to PC. I think all of you know corresponding angles, alternate angles. So first one, that is your proof, statement and reason. Now see your students, it is given that AD is what? Parallel to what? PC and AC is the transversal. AC is the transversal. AD is parallel to what? PC. AC is the transversal. So this angle and this angles are which angles? They are alternate angles. So first statement, AD is parallel to what? PC and AC is a transversal. AC is a transversal. Right friends? Then which angles are formed? Alternate. That is angle DAC is equal to angle what? ACP. They are which angles? Alternate angle. Okay, now come to the second. Once again the same parallel line, but the transversal will be different. AD is parallel to what? PC. First we take this one, the second one. AD is parallel to what? PC. BA is a transversal. BA is a transversal. So which angles form this angle? So this angle and this angles are which angles? They are corresponding angles. What is that? Angle BAD is equal to angle what? APC. Which angle they are? Corresponding angle. Corresponding angles, right? Then the third step. Now AD is the what? AD is the bisector. What the bisector does? It divides the angle into two equal parts. So this angle and this angles are equal. So I can say BAD is equal to angle DAC. Reason we can say ray AD bisects angle BAC. Right? So from 1, 2 and 3, what we can say that this angle and these angles are equal. See here properly. See here, this angle and these angles are equal. BAD and DAC. If these two angles are equal, these two angles are also equal. So we can say from 1, 2 and 3, what is that angle ACP is equal to angle APC. Reason from 1, 2 and 3. Now you can say these two angles are equal. This triangle is which triangle? It's an isosceles triangle. What is that? Isosceles triangle. Now see the fifth step, friends. The fifth step. Do what he said now. These two angles are equal. So we can say triangle ACP is an isosceles triangle. What's that? Isosceles triangle. Therefore, what we can say? If the angles are equal, the opposite sides are also equal. So I can say AC is equal to what? AP. Reason, converse of isosceles triangle theorem. Okay? Then the sixth step. Since we say that AD is parallel to PC, I think all of you know the first theorem what we did. If the lines are parallel, the ratios are what? Same. So we can say here BA upon what? AP. BA upon AP is equal to BD upon what? DC. Which one? It is basic proportionality theorem. Basic proportionality theorem. So from 5 and 6, in the place of AP, what you can write here? AC. So from 5 and 6, what you can say? BA upon what? AC is equal to BD upon what? DC. So from 5 and 6. Okay, clear? Understood?